We're really excited about this interview. A company called Metallicis in Britain is working and has developed a method of processing and producing exotic metals such as tantalum using far less energy and far fewer toxic chemicals than traditional processes. We are joined now by the boss of the company, Dion Vaughan. Dion, thanks so much for coming on the show.
Thank you very much.
If I could summarize your technology right now to produce metals like tantalum or titanium that have a very high melting point, enormous amounts of energy are required and some pretty nasty chemicals. You've essentially worked out a way of doing it chemically, in part by using molten salt.
Absolutely. Essentially, it's an electrochemical process that's been under development for a number of years now. But the process basically involves taking a metal oxide and putting it in a calcium chloride bath, and that is reduced with the oxygen from the metal being taken out, and you're left with a pure preform, or you can make an alloy in combination with other oxides.
Now, tantalum is, I mean, it's a fascinating metal. It's very non-reactive, so it's used in surgery and cranial plates and stuff like that. I believe it's used in spacecraft as well. You're already producing this stuff from a pretty small factory. It's only the size of a house.
Yeah, well, it is. It's a big house, but a house nonetheless. But yeah, we're making some interesting batch materials for customer qualification, and the early part of next year we're really kind of starting to scale up for kind of substantial industrial activity on our side. So that would probably be about 60 tons per annum of tantalum, which is quite a bite out of the world market.
Is it 3 or 4%, am I right in saying?
About that, yes.
But titanium is the big prize. I mean, the military use it, the aircraft industry use it. You'd need a much bigger plant to do that.
No, absolutely. Going forward, the two strands of our business strategy are essentially to set up a tantalum manufacturing facility, which is really coming online, as I've just said, next year. And beyond that, we are looking at scaling up with titanium. That's going to require, bigger industrial units, but we've got our plans and our financing, kind of worked out for that. Titanium really is the kind of big prize. It's a wonder metal. It does, it's light, it's strong, it does most things that steel does, but it's corrosion resistant as well. Its only major problem with it is it's very expensive, which has rather kind of limited its production worldwide to around 140,000 tons per year.
Is there any, I'm not sure if tantalum is a conflict metal, but is there any chance that you could be producing some of these metals that are now produced by slave labor, frankly, in Africa? Is there some way you could make other sources of these metals more economic?
Well, absolutely. I mean, it is a big, issue for the kind of tantalum supply chain, conflict-free materials. Actually, the amount of material that comes from distressed states in Africa is relatively modest, but it is an important part, or has been historically, of world usage. What the tantalum industry is doing globally is to try and find ways of ensuring that, conflict-related materials are not kind of, passed into the supply chain. Where the Metallicis process can add real value is not only in being more efficient in terms of, producing tantalum from, oxide materials, but it can also recycle scrap materials, which will add more tantalum atoms back into the supply chain, if you like.
Will your technology, if it's widely adopted, have a big economic impact, do you think?
Oh, undoubtedly. We believe it's going to be really successful, but if it works across tantalum and titanium, then it could work through many transition metals across the periodic table and other non-transition metals. So there are very few elements in the periodic table where this technology couldn't, touch positively in many ways.
Yeah, apparently neodymium, rare earth, that's very important, could be amenable to this. Who are you selling the tantalum right now to? Can you give us any indication?
Well, at the moment, we're at the early stages of our own kind of sales plan, and we're talking to a number of intermediates and working with them and making kind of, early steps into the kind of sales process. Ultimately, the customers of our materials will be the kind of the big users of tantalum, people in the biomedical field, people that use tantalum for orthopedic hip implants, for maxillary facial implants, these kinds of things. But they're also used for tantalum capacitors, which is a very important usage of tantalum. So the big passive, components players are, key customers for us going forward. And so these kind of capacitors end up in the kind of the back of your mobile phone, the back of your computer. They're used in, demanding applications in space and downhole wells. Tantalum capacitors are really at the kind of tip top of the kind of tree in terms of, passive electronic devices.
We'll have to leave it there. Dion, thanks so much for joining us.
Pleasure. Thank you.
Dion Vaughan of Metalysis. The company's not public, but it has attracted venture capital money.